PPT is visible to everyone?
Yes, sir.
I will give just overview on all normal forms. Just a brief on each normal forms, right? Normal forms. What first normal form says? The first normal form says the given functional dependency, right? The given functional dependency should not contain it should not contain multi-valued should not contain multi-valued and composite attribute. Right? It should not contain multi-valued and composite attribute. Right? Means if the table or if the given functional dependency is having, if any of the one attribute is having a multiple value, or if any attribute can be decomposed into number of sub attributes, if that type of attributes are present on the table, then that table is violating first normal form. Right? How to recover that one? There are three ways or three techniques we are going to apply on the table. With the help of those three techniques, we are going to resolve that first normal form. Right? The first technique is we are just going to write the new tuple. Right, for the which attribute is having a multiple value, we're going to write a new tuple. Right, the same attribute or the same tuple is going to be repeated multiple times on the table. Right, and what is the disadvantage if by using this technique means if the primary key is there on the table, so multiple attributes, nothing but duplicate values will be not allowed by that primary key. So what we will do, we're going to combine other attribute with the primary key. By this, that problem will get resolved. Right. Second one, we just decompose the table into new table. That is the second technique. The third technique, we're just going to decompose. I think we're going to split the attribute, say that attribute into multiple attribute on the same table. Right. For example, if you have multiple phone number, we're going to write phone number 1, phone number 2, phone number 3. So we have to see that the attribute name should be unique in the table. The same attribute name we can't repeat on the table. Phone number, phone number. If the table is having, if a person is having a multiple phone number, we can't write the same attribute name phone number multiple times on the table. The attribute name should be unique. That thing we have to see. That is what first normal form says. Right. When it comes to second normal form, and one more thing in first normal form, whatever the functional dependency they will give, right, all table will satisfy the first normal form, because during conversion from ER diagram to the relational schema, there we already performed that one technique in that first technique of the first normal form. That's why each and every relational schema or each and every functional dependency, whatever they will give, each table will satisfy the first normal form. No need of checking the first normal form. Right? If they give any functional dependency to check, we're going to check with the second, third, and BCNF, not a first normal form. Okay, each table will always satisfy the first normal form. It will not violate the first normal form, because while conversion from ER diagram to relation schema, we will use one of the step there, multiple attribute. We're going to create the new table. That's why first normal form, that violation is already resolved during the ER conversion to the relational schema. Right? So if they give any table, each table, every table will satisfy the first normal form. Okay, when it comes to second normal form, if you want to apply the second normal form on the table, first the table should satisfy the first normal form. As I said, each and every table, it will be a first normal form. The table should be in first normal form. This is the first basic condition to apply to check the second normal form. Second normal form says no partial dependency should be there. No partial dependency. No partial dependency is there. If the table is having a partial dependency, then we can say that that functional dependency or the table is violating second normal form, right? How to overcome or how to find out whether the table is having a second normal form or not? Okay, that we have a formula to find out the partial dependency. That is, partial dependency is equal to proper subset of candidate key should be determined if it is determined non-prime attribute. Non-prime attribute, right? This is the formula to find out, or this is the way of finding whether the table is having second number form or not. You just note on this formula. While explaining the problem, I will use this formula or this how to check this condition on the given table. Okay, how to find out the partial dependency on the given table? Nothing but second normal form should satisfy the full functional dependency. If any of the dependency or if any of the determinant is violating second normal form, is that is a partial dependency. The table is having a partial dependency. So how to find the partial dependency? The proper subset of candidate key determines the non-prime attribute. Okay, you know prime attribute, right? So while solving the minimal set or to find out the candidate key, we have used the prime attribute. Non-prime attribute, yesterday I have explained a few on the non-prime attribute in yesterday's class, right? So how to find out the non-prime attribute and all, I will explain in the problem. Okay, you know how to find out the candidate key, correct? So once we find out the candidate key, see for finding out the normal form, means if you want to solve the normal form problems, the basic we should know how to find out the candidate key on the table, because on this candidate key only we're going to find whether the table is having normal form or not, which normal form that the table is violating. We can find out with the help of candidate key. This is again the second normal form. When it comes to third normal form, okay, the main basic thing in the third normal form is that it should satisfy the, it should be in second normal form and no transitive dependency should be there, right? If the table is having a transitive dependency, then the table is violating third normal form. How to find out the transitive? You know how what is the transitive dependency, right? So transitive dependency nothing but x determines y determines z, then x determines z. This is what transitive dependency means. Here we are going to trying to find out the third normal form on transitive dependency, basically on the non-prime attribute. Non-prime attribute, right? Example, in the employee table, as I was taking, right, regular employee table. Right, so employee table, I have employee table. Okay, employee ID, then employee name, then salary, then address. Okay, we can make this address, we can split this into state, then city, then country. Okay, this is violating first normal form earlier, so that's why that composite attribute we have made into split it into number of sub attributes. Now it is in first normal form, second normal form. You can consider that it is a second normal form. Okay, employee ID has 1, employee name has something like Ram, salary 20K, state Karnataka, city Bangalore, and country is India. Okay, employee ID is 2. Okay, Sham 30K, Karnataka, same will take Bangalore, India. We can add one more pin code. Okay, this is important. pin code, something I will take. Then on 40. This one I take Rajasthan. Then like Kanpur, India, something like 7899 triple nine. Okay, this is the table, right? So what functional dependency? If the employee ID is determining any of this attribute, this employee ID is the candidate key, right? This employee ID is the candidate key, nothing but a prime attribute. Okay, why we saying this? Why we saying this employee ID is a prime attribute? Because the attribute which is involved in forming the candidate key, right? Candidate key, whatever the attributes are involved to make that one dependency as a primary key or a candidate key, right? So we can either we can say it as a candidate key, or we can say it as a primary key. We can say it as a prime attribute. Okay, if any of this prime attribute determines any of this attribute, then that is valid. Then that is valid. It is not violating any normal form. I mean that if any prime attribute determines any of the attributes, because in this table we have only one prime attribute, that is only one candidate key, employee ID. So if employee ID determines any of the attributes in the given table, then that is what? That is valid one. Okay, then it is valid one. We can say that these are all non-prime attributes. What are e-name, salary, city, state, country, pin code? These are all non-prime attributes. This is valid one. But sometimes in the table, how the functional dependency will be like non-prime attributes. For example, here with the help of pin code, I can find out the state, city, and country. Right? With the help of pin code, I can find out the state, city, and country. Means this non-prime attribute determining the non-prime attribute only. Okay, this non-prime attribute determining non-prime attribute, then this is a not valid one on the given table. Like this type of dependency, if you found on the table, right, then it's violating the third normal form. It's violating the third normal form. Means we can say that pin code is determining city, then city is determining state, then pin code can determine state. If this type of dependency we found on the table, means like transitive dependency on non-prime attribute, right? I'm specifying that one. Transitive dependency on non-prime attribute. If the same transitive dependency we found on the prime attribute, that is valid one. For example, employee ID determining salary, salary determining country, then employee ID determines country. This is valid one because this transitive dependency is performing on the prime attribute, not on the non-prime attribute. If the table is having non-prime attribute, that is showing the transitive dependency, then that type of violation we say it as a third normal form. Okay, non-prime attribute determines non-prime attributes, then this is a invalid one. Then what we're going to do? Same thing, we're going to decompose. We will make one attribute is pin code as a primary key in the separate table, split table table, other table. We'll decompose this table into different table, right? In the split table table, we'll be having this pin code as a primary key. We'll make this as a primary key. Then this will be acting as a prime attribute, determines the other attribute. That is how we go into perform, right? This is regarding the what theory of the third normal form, right? Then we can check with the help of this condition, non-prime attribute, nothing but x side should be a non-prime attribute. If right hand should be also a non-prime attribute, then this table is violating third normal form. This one thing. Second thing, in the second way, we can find out the table is having a normal form. It is violating third normal form or not. What? The condition is that, as I said, it should be in second normal form, and it should not be in interdependency on non-prime attribute, right? So how to check whether the table is violating third normal form? We have to check the left hand side, that is LHS, left hand side LHS, that is X attribute. X attribute should be super key. We have to check whatever the attribute they will give at the left hand side, that left hand side attribute should be a super key, right? Then this is the one condition. Second condition, if this is not satisfies, left hand side attribute is not a super key, then we have to check the right hand side attribute, it is RHS, right hand side attribute, it is Y should be prime attribute, whether X should be a super key or Y should be a prime attribute. If either any of these conditions satisfies, then we can say that the table is not violating the third normal form. I will repeat, the left hand side attribute X should be a super key, and if it is not, if the left hand side attribute is not a super key, then we will check the right hand side attribute. Okay, then right hand side attribute should be prime attribute. Either any of this one condition satisfies on the given functional dependency, then that dependency is not violating the third normal form. This is how we have to check whether that table is violating third normal form or not. Okay, this is regarding third normal form. When it comes to Boyce code normal form, BCNF, Boyce code normal form, right? So Boyce code normal form, it's a higher version, a stricter version of the third normal form. What third normal form says that this X side also should be, if X side is a non-prime attribute, then we're going to check the right hand side attribute. If it's a non-prime attribute, then we are saying this table is violating third normal form. But when it comes to BCNF, we're going to check only the left hand side attribute. If the left hand side attribute satisfying which condition, the left hand side attribute should be a super key, nothing but should be a prime attribute. Should be a prime attribute. Then only we can say that this table is not violating the Boyce code normal form. If left hand side attribute is not a super key, then we're not going to check the Y side, that is RHS side, we're not going to check only. Right? Straight away we're going to say that this table is violating the BCNF. Okay, right? It's a higher version. BCNF is the stricter version. The version of the third normal, right? And here we're going to check only left hand side. If left hand side is a super key, then the table is not violating the BCNF. If it is not a super key, rejects is not satisfying super key condition, then obviously the table is giving a Boyce code normal form violation. This is regarding how to check on this on the given table. Okay, the first normal form, second normal form, then third normal form, then the BCNF. This is regarding what? Just an overview on the BCNF.